Hey everyone, this is Mr. Ziegler here. I'm going to go through your Wednesday assignment. All right, so here we have the notes. Whoops. And underneath, you're going to click this Load Atomic Structure Notes in a new window, and it should pop up and look like this. I'll move my head over here. All right, now over on this side, I'll go through the slideshow, and then over on this side, I'll go through the notes. Let me maybe open up this pen so I can draw if necessary. I'll leave it right there. I'll leave it right underneath here. All right, so to start, draw or type two things you already know about today's topic, which is atoms. So anything that you know about atoms, even if there are some things that maybe you've heard or you're not sure if it's correct, or maybe just questions that you have about atoms, make sure that you get two things in your notes here. So if I click here, that's our first one here. You got to get two things down about atoms. Okay, once you do that, we're going to go through some atomic structure, which is how the atom is built, the structure of the atom. All right, so first, the atom is the smallest unit of matter. So I'm going to take notes with you here. We're on the atom. The atom is smallest unit of matter, and that different atoms have different properties. Okay, different atoms have, ran out of room there, different properties. Now, my boxes here, they don't expand when I write, so yours should expand when you write. So mine might go into the protons, but I'll clear that off, and I'll do that next. So there are smaller particles called subatomic, like sub means underneath, like a submarine goes underneath the water level. So subatomic means that they're under the atom or smaller than the atom, and they have constant properties. So atoms have different properties. If we have a copper or a hydrogen or an oxygen atom, they all act differently. All right, but the parts that make up that atom, these subatomic particles, it doesn't matter if they're in an oxygen atom or if they're in a copper atom or a hydrogen atom, they all have the same properties. They're all the same. So one of those properties, here we go. Let me clear here, is a proton. So a proton, four things that we need to know about it. Number one, it has a charge equal to +1, a +1 charge. So a charge can help kind of like create this electricity. Protons have a positive charge. The weight or the mass is equal to 1 AMU. Now, an AMU is super, super, super tiny. And so if we actually get the weight of a proton, it's so small that we actually have to write like 0 point and then a bunch of zeros in order to show it. So to make it a little bit easier, we call it 1 AMU. But don't let that confuse you. That doesn't mean like 1 gram. It is super, super light because protons are so small. An atom is so small we can't see it. A proton is even smaller because it helps make up an atom. The location, where would we find it in an atom? The location is in the nucleus, and the nucleus is the center of the atom. So if I go back here, one more. Right here, all right? So you've probably seen that picture in the background here for an atom. This thing right in the center, that is the nucleus, all right? And that's where we're going to find our protons. And the last thing, kind of a special property for protons, they change the name. Change name of atom. So if we have one proton, it's got a certain name. If we have two protons, it's a totally different name, and it actually behaves totally differently than what it did before, even if the only thing we changed is just one tiny proton. All right, if we add one or if we subtract one away, the atom behaves completely differently. And so that's special property of protons. They change the name of the atom. All right, let me scroll down a little bit here. Now let's go to neutrons. Neutron, three properties. Charge is 0. Sometimes we'll say it's neutral. All right, it's 0. Kind of like in a car, if you put a car in neutral, it doesn't move forward or backwards. It just stays there. All right. The weight or the mass is 1 AMU, same as the proton. So it's basically the same size as a proton, has the same weight. The location is also in the nucleus. So it's right next to the proton. So far, everything about the neutron and the proton has been the same, except the neutron has a 0 charge and the proton has a +1 charge. All right, special property, the neutrons affect the stability or the radioactivity. So you've probably heard of something that's been radioactive before. And what that means is the atom is unstable. All right, it's unstable. It can kind of fall apart or blow up. All right, so it can break apart into different pieces, and that is radioactivity because it is unstable. All right, so we did 2 parts of the atom. There's one more remaining. The electrons. The electrons. So an electron, the charge is now -1. And electrons are actually what cause electricity. That's where the name comes from. So it's the negative charges. This is just bonus information. The electrons are moving, all right, and that causes this electricity. But when they move, the proton is left behind, and that leaves a positive charge behind it. All right, and we'll talk more about charges later here. The weight is 0 AMU. So we talked about how 1 AMU is so super tiny. We'd have to have like 0 point and then a bunch of zeros for it to even be a gram, or for it to be measured in grams. The electron is so much smaller than a proton that its weight is still basically 0, even though it's a subatomic particle just like a proton is. The location, all right, now this is where we get different. This is a different location. The location, sometimes we call them electron clouds or orbits. And sometimes you'll hear shells. There's a lot of different names for them. But let me go back to the picture here. These are electrons, and you can see these orbits that kind of go around. Sometimes it's more of like a cloud or a shell that these things are moving on. But that the electrons are outside of the nucleus. And a special thing about electrons, they affect the bonding, how atoms stick together. So we've mentioned like H2O before is water, and we have H's and O's, and they're bonded together. They're stuck together. The electrons are what affect that. All right, depending on how many and kind of the location of the electrons, we can get different atoms to bond or stick together in different ways. So that bonding, how they bond, we call that reactivity, not radioactivity, reactivity. It's how atoms react. So have you heard of chemical reactions before? That's all based on these electrons here. So it's based on the electrons, how things react with each other. And that's how we get chemical reactions. All right, so now a little quiz here. Draw lines to match the image to answer. You can double click to edit. So if I double click this, okay, now I can draw on here to connect them. So you can choose like this line here and you can actually connect them. I'm just going to use my pen here to draw on it. So we have nucleus, we have orbitals, we have charge, mass or weight, affects atom type or name, and affects reactivity and bonding. So what I'm going to ask you to do is I'm going to ask you to review your notes and see how these connect. And some things might have multiple things connected to them. So maybe all three of these things are connected there. All right, that's okay. But try to use different colors so things kind of stand out a little bit more. And so I can see how you connected these. All right, I'm not going to give you the answer to this one. I'm going to go back and check to make sure that you are paying attention to your notes. All right, whoops, let me clear that. Now, how do I get out of here? Whoops. There we go. All right. Next, periodic table symbols. All right. So, real quick, bonus information. Bonus info Wednesday. When an atom has a neutral charge, all right, so when atoms have a charge of 0, okay, what must be true? All atoms must have protons, and all atoms must have electrons. They must have both. So if we have a 0 charge, they must be equal. We might have 10 protons and 10 electrons, so that's 10 pluses and 10 minuses. We might have 5 and 5. We might have 20 and 20. We might have like 192 and 192. It doesn't really matter, all right? But we know that they must be equal to each other. So there are going to be some questions where they're going to ask for you to find the amount of protons or find the amount of electrons, and they'll give you the charge. If they give you the charge, you know that those two numbers are the same, okay? So when an atom has a positive charge, okay, when it has a positive charge, that means that it has more protons. And it has, whatever that positive charge is, let's say it's 2, then that means that we have 2 more protons. If the positive charge is 5, that means we have 5 more protons. When an atom has a negative charge, we have more electrons. Same idea as before. If we have a negative 2 charge, we have 2 more electrons than protons. Okay? Now, one thing I will mention, electrons are a lot easier to change than protons. So when we get into these problems, a lot of times we'll find our protons first, and then if we have a positive 2 charge and we know we have 5 protons, then we have to have 2 less electrons, okay? Because I know I have 2 more protons, so how many electrons would I have with a plus 2? We'd have 3, okay? And we'll go through that more here in a little bit. All right, periodic table. So this is what it will look like on the periodic table. We'll have these boxes. We'll have the atomic number. Now, it says right above it. Sometimes it'll be slightly to the left or slightly to the right. So we'll have carbon here. This 6 might be up there, or in some periodic tables, it might be over here. All right, generally, let me do it again. Generally, I think it's over here on the left-hand side. All right, so this is the atomic number. Atomic number. Okay, and that is always the number of protons. There is no trick. If you know the atomic number, it is the number of protons. It's always the same. Okay, this is the symbol. Maybe let me change colors here. I'll just have it stand out a little bit better. That's the symbol. You will not need to memorize these or anything, but it's just it's the symbol we use to show that it's carbon without actually writing out that it's carbon. We'll just use a C for it. The one key thing is that there will only be one capital letter for each symbol. So some might have 2 letters, like copper is Cu, but that U has to be lowercase. If you have 2 capital letters, you have 2 different types of atoms. All right, and we'll have the element name. Sometimes, depending on the periodic table, some of them will write them out here. Some of them won't. And then underneath, we'll call the mass number. So let me put this in red. Okay, this is 12. Okay, technically, the mass number will never be a decimal. All right, so what we normally do is we'll take this decimal, and this is called the atomic weight, which we'll talk about later. All right, but this is kind of an average atomic weight, and so that's why it's a decimal. But a mass number, we're always going to round to the nearest whole number because it'll always be a whole number for the mass number. And so 12.01 the nearest whole number is 12. That's the mass number. And that will always be the protons plus the neutrons. Now, how can that be helpful? One, is just information about the atom. But two, I'm always going to know, I shouldn't say always, but a lot of times I'm going to know the atomic number, which is the number of protons. So if I have 12 here, I know 6 of the 12 are protons because I know this is protons and neutrons. I'll put this protons plus neutrons. So it's going to be 6 plus my neutrons, which is blank, equals 12. And that can always help me figure out how many neutrons there are. So we're really going to focus on finding the number of protons, neutrons, and electrons for this atomic structure. All right. That's it for the notes, but I have some quiz questions here I want you guys to try out. So first, how many electrons, protons, and neutrons must a neutral carbon, atomic number 6, atom with a mass number of 12 have? So I'm going to write protons, neutrons, electrons right here. Okay, you can pause this video so you have a little bit of time to solve it. Use your notes to help you, and then I'll go through the answer here. So go ahead and pause it. Welcome back. All right, so here we go. Atomic number is 6. That's our protons. Always. Atomic number. Okay, neutrons. Okay, it doesn't tell me how many neutrons, but this mass number helps us. Remember, mass number equals protons plus neutrons. So if I write an equation, it's like 12, that's my mass number, equals my protons, 6, plus my neutrons, blank, x, question mark, whatever you want to write there, okay? So to solve this, because 6 is being added to x, I got to subtract it. Subtract 6 from both sides, and so I should have 6 neutrons. All right, 12 minus 6 is 6. 6 plus 6 is 12, so that's how I can figure it out. Now, electrons. Again, it doesn't say anything about electrons, but here's the key. Neutral. Neutral means it has a 0 charge. If I go back, oh, here we go. All right, if we have a neutral charge, which we just did, the electrons and the protons must be equal to each other. So I have 6 protons, I have 6 electrons. Why is that? I have 6 pluses, 6 minuses. They cancel each other out to be 0. All right, let's go to the next one. Same thing, protons, neutrons, electrons. How many electrons, protons, and neutrons must a lithium atom, which has an atomic number of 3, with a mass number of 7 have if it has a total charge of +1? Again, pause, try to figure this out yourself, and I'll go through the answer in a bit. Welcome back. All right, here we go. Atomic number. Atomic number is always number of protons. That's 3. Boom, we got that one. All right, no trick there. Those things are always matched together. All right, mass number is 7. Remember, mass number equals protons plus neutrons. So if I replace that, mass number is 7. Protons is 3. 3 plus blank, 3 plus x, 3 plus question mark, whatever you want to call it, equals 7. We can mathematically solve and like subtract 3 from both sides. All right, or sometimes it's just easier to do in your head. 3 plus what equals 7? The answer would be 4. So we have 4 neutrons in this case. All right, now it has a total charge of +1. Okay, so that means I have more protons. Now, I already have the number of protons. I cannot change that. So I know I have one more proton because it's a +1 charge than electron, which makes this 2 electrons. You could write out an equation if you wanted to. You don't have to do this. Charge is equal to protons minus electrons. Okay, so +1 equals 3 minus blank or x or question mark, and that's going to be 2. All right, the hardest one yet. I think this is the last one. Yep, we'll do this as the last one. All right, how many electrons, protons, and neutrons? So P, N, E. All right, must an oxygen atom has an atomic number of 8 with a mass number of 16 that has a total charge of -2. Go ahead, pause. I'll see you in a bit. Welcome back. All right, here we go. Protons, 8, because that's its atomic number. Boom, no trick. All right, mass number. We're getting the hang of this now. Mass number equals protons plus neutrons. Plug in the numbers. 16 equals 8 plus blank x question mark. Whatever you want to write there, okay? We can mathematically solve, subtract 8, or sometimes it's easier. 8 plus blank equals 16. The answer is 8. 8 plus 8 is 16. Now electrons. Okay, here's the tricky one. Let me erase so I have enough room. Okay, total charge of -2. So I must have more electrons because it's negative. How many more electrons must I have? 2, because it's -2. So we could write out an equation if we wanted to. Charge equals protons minus electrons. Sometimes it's easier to say, oh, I have 2 more electrons. Protons is 8. I can't change that. I already got that locked in. So electrons must be 10 because 10 is 2 more than 8. If we do it by the charge, we would say -2 equals protons, which is 8 minus blank. Okay, so we got to get to -2. So I know 8 minus 8 is 0. So 8 minus 9 would be -1. 8 minus 10 would be -2. And we get 10, which is what we got here. So that's the notes for today. Hopefully that was helpful. Don't forget to subscribe. Okay, get on the subscribe train. All right, don't be the last one on. And I will see you next time.